Hi everyone. In this video, we are going to learn about the chain rule and why exactly are we using the chain rule if we are using it. So let's see the first question, which is q of x is equal to x square plus 1 whole square. Now we know that what we can do for this simple question is we can just say that q of x is equal to x to the power of 4 plus 2x square plus 1. This is probably the expansion of x square plus 1 whole square by the identity a plus b whole square. Right. Now, differentiating this would be very easy. That will be q dash of x, that will be equal to 4 x to the power of 3 plus 2 times 2 is 4x, and plus 1 differentiation of a constant is 0. So the answer will be 4x cube plus 4x. Correct. Now, this was an easy question with an easy power to be expanded. But if I come to this question, which is question number 2, and here the power is 30, correct? If power is 30, I probably will have to use binomial distribution in order to work on it. And if I'm going to use a Pascal's triangle to find out the coefficients and all, that would be way too long. So for this reason, we got to a rule called chain rule, where we exactly find out what is the differentiation of these larger powers. We'll be able to find out the differentiation of the larger powers or the questions that are not, doable this way. Correct. So now let me explain to you the same question with the help of the chain rule, and we'll see that if the chain rule applies here also, that means that it will be applicable in the questions like these. So if I have to differentiate this, now we know that this function over here, x square plus 1 to the whole power of 2, is a composite function. It's a function inside a function, right? And if I have to differentiate this, what will happen? It is differentiated in a way like we differentiate this, keeping the inner function as it is, right? Because the differentiation of f of x is f dash of x. So f of g of x will be f dash of g of x, and then g of x is again differentiated. That is how the chain rule works, and this is what the q dash x, that is the differentiation of q of x looks like, right? So now if I apply the same strategy here, that means if I differentiate x square plus 1 to the whole power of 2, I'll get 2 times x square plus 1 times to the whole power of 2 minus 1, which is 1, and times it by the differentiation of the inside function, which is 2x plus 0, right? So this can be written as 2 times x square plus 1 times 2x, because power 2 take away 1 is just 1. And now if I'm going to expand it, I'm going to get 2 times 2, 4x times x square plus 1. If you will simplify, it will become 4x cube plus 4x, which is exactly similar to this differentiation. That means it holds good for this question. So hence the same chain rule will be applicable to the questions like this, making our tasks a little easier when we are dealing with the larger powers. So that will be 30 x square plus 1 to the power of 29, and times it by the differentiation of the inside function, that will be 2x plus 0. So this will be, final answer will be 30 times 2x times x square plus 1 to the power of 29. I wrote it in a manner because I had to solve this one. So I'll do 60x finally, and times it by x square plus 1 to the whole power of 29. That's your final answer. If there's any doubt, you all can put into the comment section below. Correct. So here we go for the definition of the chain rule, that if g is a function which is differentiable at x, we saw it, that this g was a function that was differentiable at x. F is differentiable at g of x. Now, whatever this g was differentiable at, f should be differentiable at that particular variable, right? So, it was very much so over here. Hence, then the composite function qx, which is equal to f of g of x, is differentiable at x, and it looks like this: f dash of g of x times g dash of x. That means differentiation of f of g of x and then differentiation of the inside function g of x, right? So now if I'm going to apply, let's say I'm still going to check the chain rule for this function also, which is x to the power of 4 plus 1 to the power of 3. Okay, it is a plus b whole cube, so that looks like a cube plus b cube plus 3a square b plus 3a b square 1 square. So it will be x to the power of 12 plus 1 plus 3 x to the power of 8 plus 3 x to the power of 4. If you will differentiate this with respect to x, you will get 12 x to the power of 11 plus 0 plus 24 x to the power of 7 plus 12 x to the power of how much? X to the power of 3. Let's see by the chain rule I get the same thing. So q dash of x, now we are going to find it by the chain rule. So 3 times x to the power of 4 plus 1 whole square times differentiation of this function also. This function means whole of it, like whole. So 4x cube plus 0. Let's simplify. 3 times x to the power of 4 plus 1 whole square will be x to the power of 4 square plus 1 and plus 2 times x to the power of 4 times 4x cube. Simplify. 3 times 4 is 12x cube times x to the power of 8 plus 1 plus 2x to the power of 4. Simplify more. 12 x to the power of 8. So x to the power of 8 and 3 will add up. So it will become x to the power of 11 plus 12x cube plus 24x to the power of 12. No, 7, sorry. Yeah, 24x to the power of 7. So you can see over here, we've got the same function. So we have the same differentiation. 12x to the power of 11 plus 0. 0 I didn't write purposely. Then 24x to the power of 7 plus 12x to the power of 3. So we got it. That's it. Next is q of x is equal to sine x squared. I'm going to solve it on the next page. Let's say the third question was q of x is equal to sine of x squared. So the differentiation of sine x is cos x, cos of x squared. And what is the differentiation of x squared? That will be 2x. So 2x cos x squared. Next, sine x squared plus 5. The differentiation I did right now for sine was cos of x squared plus 5, and differentiation of x squared was 2x, so times it by 2x, because 5 is not differentiable. I mean, constants are, differentiation of a constant is 0, so just 2x. The final answer will be 2x cos x squared plus 5. Finally, we have cos of root x can be written as cos of x to the power of half if I would put it inside a qx function. So q of x is equals to Now differentiation of cos is minus sine f x, and differentiation of x to the power of half is how much? I'll do it. So x to the power of half, if we have to differentiate, that will be, so d by dx of x to the power of half will be half of x to the power of minus half. That will be 1 upon 2 root of x. So we'll just put it over here, 1 upon 2 root of x. That is your final answer. One question, this one appears in the examinations. Given that h of x is equals to f of g of x, we have to find out the h dash of 3. Okay, h dash of x is equals to f dash of g of x times g dash of x. So if I'm going to put 3 over here, that will be f dash of g of 3 times g dash of 3. Plug in the values. F dash of, what is g of 3 is 4, times g dash of 3 is given 6. So now f dash of 4 we have is 8. 8 times 6, 48 is the answer. That's it. I think this is it for the video, and I'll see you in the next class. I hope you understood the chain rule though. Take care.